Assalamualaikum warahmatullahi wabarakatuh. So this is video for lecture on week 3. So we are still not finished our chapter 1. So for today we will continue with the new subtopic, which is the continuity. Okay. How do we know whether a function is continuous or not? So if the function is continuous, when we trace the function's graph, so we trace the function's graph without lifting the pencil from the graph, so we can say that the function is continuous. Meanwhile, if we trace the function's graph with lifting the pencil, so we can say that the function is not continuous or discontinuous. For example, let's say we have this graph. This graph. So we want to know whether this graph is continuous or not. So take out our pencil and try to trace along this graph. We trace along this graph. So we can successfully trace this graph without lifting our pencil. So this is the example of continuous graph. The example for discontinuous graph or not continuous graph is like this. So when we trace our pencil along this graph, so start from here into here, and then we continue with this line here and at the end of the graph. So we can see that from here to here, we lift our pencil. So this is the example of discontinuous graph, or the graph that is not continuous. It is easier to determine whether the graph is continuous or not continuous by seeing the shape of the graph. But if you are given only a function without the graph, so how can you determine whether the function is continuous or not? So that's the thing that we will learn in this subtopic. In the previous subtopic, the subtopic about the limit, we noticed that the limit of a function as x approach a can be calculated by simply substituting the value of a into x. So let's say we have the limit x approaches 2 for the function of x squared plus 1. So we can simply substitute the value of the value 2 into the variable, so it will become 2 squared plus 1. So the answer will be equal to 5. So the function that have this property is called continuous at a. So this for this function, for this case, we can say that the function is continuous at x equal to 2. It means the graph of the function is not disconnected at the particular point x equal to 2. So how do we determine whether a function is continuous or not at a certain point? So there are 3 conditions for us to determine the function is not continuous or not. The first one is fa is defined. Fa is defined. A is the point that we want to test whether the function is continuous or not. The second condition is limit x approaches a. For that function must exist. And number 3, limit x approach a for that function must be equal to fa. So the first condition states that the function must be defined. Okay, this means that the value of a must be in the domain of x. So meaning that when we substitute the value of a into that function, okay, we will get a value. Okay, so maksudnya it is defined. And then the second condition states that the function must the limit of the function must exist. Okay, so how do we know whether the limit of that function is exist or not? So let's recall what we have learned in the previous subtopic. Okay, in the previous subtopic we have this formula. Okay, which the formula stated that if the left limit and the right limit is equal to 5, okay, therefore we can say that the limit, okay, itself is equal to if the left limit and the right limit is equal to 5, and we can say that we can conclude that the limit of the function is equal to L and the limit is exists. So this is how we determine whether the limit is exist or not. Okay, it is stated in the second condition. So for this second condition, what we have to do is okay, we need to determine the values of left side limit and the right side limit, whether it is equal or not. Okay, so you all kena buat working solution. Okay, what is the answer for the right limit and the answer for the left limit. So check whether it is equal or not. So if the values are equal, so we can say that the limit, okay, is exists. Otherwise, if the values are not equal, we can say that the limit is not exist. So if the limit is not exist, the second condition is not satisfied. So if the second condition is not satisfied, we can say that the function is not continuous. Okay, for the function is being continuous, it need to satisfy all these three conditions. Okay. Okay, then in the in the third condition, okay, the third condition states that the value obtained in the first condition, okay, which is FA, okay, FA, we can obtain FA from the first condition, okay, must be equal to the values obtained in the second condition. Okay, limit, the values of limit must be equal to FA. So we can obtain FA from the first condition, and we can obtain the values for limit in the second condition. So if the values are equal, we can say that if the values are equal, means that the third condition is satisfied. Okay, if the first condition and second condition and also third condition are satisfied, and so we can conclude that the function is continuous. And if one of these conditions are not satisfied, okay, so we can say that the function is not continuous. Okay, let's take a look at this example. Example 1.29 on page 19. Okay, so we want to determine whether this function given is continuous at x equal to 2 or not. So here we have three functions, which is the first function is 1 plus x squared for x less than or equal to 2. And the function will be 2 minus x if the value of x is between 0 and 2, and the function will be x minus 2 square if the value of x is larger than 2. Okay, to solve this question, we will only look at the functions that is related to 2 because we want to test the continuity at point x equal to 2. So we need to determine whether these functions satisfy all these 3 conditions of continuity. The first condition is f a is defined. So what is our a in this question? Our a is equal to 2, okay? Because we want to test the continuity at the point x equal to 2. So our a is 2. So we need to find f2 for the first condition. So therefore we will only use the function that has x equal to 2 in the interval. Okay, based on this piecewise function, the function that has x equal to 2 is function of x minus 2. Okay, because it has equals 2 right here. Okay, so in this case, for the first condition, we will use the function of x minus 2. So we need to substitute 2 into the variable of x in that function. So it will give us f2 equal to 2 minus 2. So it is equal to 0. Since 0 is a number, it means that f2 is defined. Okay, so the first condition has been fulfilled. Okay, so if the first condition is satisfied, we need to proceed with the second condition. Okay, we need to determine whether it is fulfilled or not. So the second condition states that limit x tends to a for that function must be exist. So for this question, our a is 2, meaning that we need to determine whether limit x approach to f of x is exist or not. Okay, so how do we determine whether our limit is exist or not? As I mentioned before, in order to know whether our limit is exist or not, we need to find the left limit and the right limit, and then see whether the values are equal or not. Okay, so this is the working solution for condition number 2. Okay, this is our left limit and the right limit. Okay, from here you can see that in the left limit and the right limit, we use a different function. Okay, different function. For the left limit, we use function 2 minus x, while for the right limit, we use function x minus 2 square. So why is it like that? This is because, okay, we have the function in term of piecewise. Okay, piecewise function. Sekejap piecewise function. Okay, so the first function 1 plus x square is for the value of x less than or equal to 2, equal to 0. Equal to 0. So imagine that we have a number line here. So 0 is here and 2 is here. So when the value of x less than or equal to 0, from here to the left, so we need to use the function of x plus x square. Okay, and then if the value of x is from 0 and 2, between 0 and 2, and equals to, meaning that from here to here and including 2, okay, we need to use the function of 2 minus x. And then if the value of x larger than 2, more than 2, meaning that from here to the right, so we need to use the function of x minus 2 square. Okay, so back on this case, case study yang second condition, okay, where we need to determine the right limit, left limit and the right limit. For the right limit, okay, maksudnya x approach 2 from the right, okay, x approach 2, here is the value of 2, so x approach 2 from the right, daripada sebelah kiri, okay, so sebelah kiri 2, kita kena guna function 2 minus x. That's why they write here the function is 2 minus x. Okay, for the right limit, limit x approach 2 from the right, okay, the value of 2 is here, so the function on the right side of number 2 is x minus 2 square, so we need to use that function here. Okay, that's why this function and this function is different, okay, for the left limit and the right limit. So we need to determine the value, okay, for left and right lah. Okay, for the left limit, okay, we just substitute the value of 2 into the variable, so we got x 2 minus 2, it is equal to 0. Meanwhile, for the right limit, okay, the same step, we need to substitute the value of 2 into the variable, so we got 2 minus 2 square, so it will become equal to 0. Okay, so the value of the right limit is 0 and the left limit is also equal to 0. Since the values on the left and right are equal, so we can conclude that limit x approaches 2 for the function of f of x is equal to 0 and it is exists. Okay, the limit is exists. Okay, so we can see that the second condition is fulfilled, or the second condition is satisfied. Okay, and then we proceed with the third condition. Okay, if your second condition is not satisfied, is not fulfilled, so you don't need to proceed with the third condition. Just write the conclusion as the function is not continuous at x equal to 2. Okay, but in this case, our second condition is fulfilled, so we need to proceed with the third condition. Okay, the third condition, what is the third condition? Third condition needs us to fulfill the condition of okay, the third condition from the notes yang tadi, limit x approach a, f of x must be equal to fa. Okay, so in this case our a is 2, so it will become limit x approach 2 for function f of x equal to f2. Okay, so we can obtain the value of f2 from this first condition. Where is our first condition? Okay, first condition is here, right here. So our f2 is equals 0. Okay, so it is equal to 0. How about our limit? Limit x approach 2. Okay, the values of limit, this limit can be obtained from the second condition. Okay, this is our second condition where we determine the left limit and the right limit, and then this is the conclusion. Okay, limit x approach 2 exists and the value is 0, so it is equal to 0. Okay, so since the values are equal, we can conclude that the function f of x is continuous at x equal to 2 because it satisfies the first condition, second condition, and also the third condition. Okay, let's take a look at the second example, which is example 1.30. This time we want to determine whether this function is continuous at x equal to 2 or not. Okay, so we are given a piecewise function. For this example, we don't have to determine whether this function is continuous or not because it is stated here the function is continuous dah. Okay, the function is continuous and we need to find the value of c. Okay, where is our c? C is right here and right here. Okay, same with the previous example, we are given a piecewise function. So be careful to choose the right function. Okay, choose the right function for the condition 2 nanti ya. Okay, so in this question, it is already stated that the function is continuous. Okay, it means that the function satisfied the first condition, second condition, and also the third condition. Okay, let us consider the third condition. Third condition stated that limit x approach a, f of x equal to fa. So here our a is 2. Okay, here our a is 2. So if they stated that this function is already continuous, it means that it satisfies that three conditions. Okay, let's consider for the second condition, which is the second condition must be satisfied. Okay, what is our second condition? Second condition stated that the limit must be exist. So in order to know whether the limit is exist or not, okay, we need to find the value of the right limit and the left limit, okay, and determine whether it is equal or not. So let's consider the second condition where the right limit and the left limit must be equal. Okay, so we need to compare the left and right limit lah. Okay, so first we need to find the left limit. Okay, for the left limit, okay, we need you need to write limit x approach 2 from the left, okay, negative here, and then choose the right function. Okay, which function that we must choose is the function on the left side of the right side of number 2. So which means it is less than 2. So we need to choose this function cx squared plus 2x. Okay, so we write the function here and then just substitute the value of limit into the variable. So we got c2 squared plus 2 times 2, and it is equal to 4c plus 4. Now we consider the right limit. Okay, for the right limit, we need to choose this function because this function is for the value of x larger than 2. Means that it is on the right side of number 2. Okay, so write that limit here and then solve. Okay, so we got 8 minus 2c. Okay, after we obtain the answer for the right limit and the left limit, we need to compare and solve them for to find the value of c. Okay, since we already know that the left limit and the right limit must be equal, so that it will satisfy the second condition. Why it must satisfy the first condition? Because it is stated that the function is already continuous. Okay, if it is already continuous, meaning that it satisfied all these three conditions. Okay, so we need to set up the equation for c plus 4 equal to 8 minus 2c and solve for the value of c. So we get 2 over 3. Okay. Okay, let's take a look at another one example which the function is actually not continuous. Okay. Okay, look at the exercise at the back of chapter 1 in this book. Okay, question number 17. Okay, we have function g where it is also in the form of piecewise function. Okay, given that there are two functions, okay, x squared minus 4x plus 2 if the values of x less than or equal to 2 and the function will be equal 0 if x is larger than 2. Okay, so we need to determine whether this function is continuous or not, and the answer is not continuous. So we need to see why it is like that. So we need to do the first condition, and then if the first condition is fulfilled, we need to proceed with the second condition, and if the second condition is fulfilled, and then we need to proceed with the third condition, and so on. Okay, so we do the first condition first. Okay, first condition stated that FA is defined. FA is defined. So in this question, our A is 2. So we need to see whether F2 is defined or not. Okay, F2, meaning that we need to substitute the value x equal to 2 into the function. So which function do we need to use, okay, for the first condition? Which function? Okay, so function yang kita kena guna is this function, because it is equals to right here, equals to, ada equal okay, we can see right here it is equal to. Okay, so we need to use this function x square x square minus 4x plus 2. So x square minus 4x plus 2. So this will become 4 minus 8 plus 2. Okay, 4 minus 8 negative 4, and plus 2, it is equal to negative 2. Okay, since it has a value, so it is defined. Okay, defined. So we can say that the first condition is satisfied or is fulfilled. Then we need to proceed with the second condition, which we need to find the value of right limit and the left limit. Okay, limit x approach 2 from the left, and limit x approach 2 from the right. Okay, so this time which function do we need to use? Okay, for the right limit, we need to use the function that lies on the left side of number 2, which is this function. Okay, so x square minus 4x plus 2. And for the right limit, we need to use the function on the right side of number 2, which means it is more than 2. So yang ni lah so the function is 0. So we need to find the value of each of these following. Okay, for the left limit, we just need to substitute the values of 2 into that function. So 2 square minus 4 multiply with 2 plus 2. So it is equal to negative 2. And then for the right side, okay, we just need to use the rule of limit. So it is equal to 0. Okay, we can see from here, the left limit and the right limit is not equal. Limit x approach to negative not equal to the right limit. So what happen if it is not equal, the left limit and the right limit? Okay, it means that the limit is not exist. Okay, so if the limit is not exist, meaning that our second condition is not fulfilled. Okay, it's not fulfilled. So we don't need to proceed with the third condition. Just write the conclusion as the function g(x) is not continuous at x equal to 2. Okay, so this conclusion is very important. Okay, you need to state that this function is continuous or not. Okay. Okay, next we proceed with the other subtopic, which is the limit of trigo function. Okay, on this page 20. Okay, in finding the limit of trigo function, it almost has no difference compared to the limit of the ordinary function. Okay, we just need to substitute the value of limit into the variable of that function. Okay, and if we got undefined value, we need to proceed with other alternative solution. Okay. Okay, for example, we want to find the limit x approach 0 for the function of sine x. So all we need to do is just substitute the value of x equal to 0. So we got sine 0. Okay, tekan calculator, dapat sine 0 equal to 0. So it is defined, so we don't need to proceed with alternative solution. For this question, the answer will be equal to 0. Okay, so but what if the given limit results in undefined form? Okay, undefined. Jawapan dia undefined. Maksudnya kalau awak direct substitute the value of a limit into the variable of function, okay, tekan calculator, dapat jawapan error, math error. Okay, so what we need to do is we can use squeezing theorem. Okay, look at theorem 1.1. Okay, this is squeezing theorem for trigo. Okay, we have two formulas here. The first one is limit x approach 0 for the function of sine x. Okay, divide by x. Okay, it will be equal to 0. And if limit x approach 0 for the function of 1 minus cos x divided by x, okay, it will be equal to 0. Okay, the first function dia mesti sin x over x. Okay, it will become 1. It will become equal to 1 only for this kind of function. Okay, sin x divided by x, and the limit is limit at 0. Okay, kalau limit at 2, limit at 3 for the same function, it will not be equal to 1. Okay, or okay, dia punya condition adalah function, this function must be in the form of sin x divided by x. Okay, x ni sama dengan x ni, it will equal to 1 lah. Okay, or sin 2x divided by 2x, sin x square divided by x square, sin 3x divided by 3x. Okay, all of that will equal to 1. Okay, condition dia adalah limit x at 0, and then for the function sin, yang ni value ni dengan yang ni mesti sama, so it will become equal to 1 lah guna theorem ni. Tak perlu nak kira apa-apa lagi, just use this theorem, it will equal to 1. Okay, yang second theorem ni, okay, and for this second theorem, okay, limit x approach 2, okay, it must be x approach 0. Okay, tak boleh x approach other numbers, and then the function, okay, mesti macam bentuk macam ni lah, 1 minus cos x divided by x. Okay, ni dengan ni mesti sama. Kalau 1 minus 2 cos 2x mesti divide by 2x. 1 minus cos x square divide by x square. Only that it will become it will equal to 0. Let's take a look at example 1.31. Okay, we want to find the limit of function limit x approach 0 for the function of tangent x divided by x. Okay, tangent x divided by x is not listed in these two theorem. Okay, tak ada tangent x divided by x, so we cannot directly use this theorem. So we need to do some modification in order for us to use to apply the squeezing theorem. So we need to modify this function. So recall that tangent x, okay, tangent x is equal to sin x divided by cos x. So therefore this function will become okay, bring out 1 over x dulu tangent x divided by x, bring out 1 over x, so it will become tangent x multiply with 1 over x. And then tangent x, okay, substitute dengan yang ni lah, sin x divided by cos x. Okay, so this original function will become this function. And then okay, and then we need to rearrange this function, okay, this function to get the suitable form for using the previous theorem tadi So okay, tadi dah sampai sini, and then kita tukar tempat dia. Okay, x, okay, letak sini, cos letak sini, so it will become sin x divided by x and 1 divided by cos x. Okay, then sin x divided by x. Okay, recall the previous theorem yang tadi. Okay, so we have here sin x divided by x yang ni Okay, ada formula sin x divided by x. So we will use this theorem. We will apply this theorem. Okay. Okay, but before that we need to use the law of limit. Okay, tadi dah sampai sini sampai sini, and then use law of limit. Okay, limit tu kita split for these two functions. So it will become limit x approach 0 for the first function multiply with the limit of the second function. So for the first term here, we can apply squeezing theorem and it will become 1. Okay, yang ni limit x approach 0 sin x divided by x equals 1 using squeezing theorem. And then for the second limit, we just substitute the limit into the variable so it will become 1 divided by cos 0, where cos 0 bila tekan calculator akan jadi 1. Okay, so it will become 1 divided by 1, okay, equals 1. Okay, now we will look at another example of the application of squeezing theorem. Okay, for this example, limit x approaches 0 sin 3x divided by sin 5x. Okay, if we directly substitute the value of limit ni dekat dalam ni, so kita gantikan x ni direct dengan 0, so it will become sin 3 multiplied with 0 is equal to 0, and 5 multiplied with 0 is also equal to 0. So we get sin 0 divided by sin 0, where sin 0 is equal to 0 kalau tekan calculator. So 0 divided by 0, it will become error lah kalau tekan calculator, error. So tak boleh direct substitute, so we need to use squeezing theorem. Okay, note that 3x and 5x are not cancelling each other. 3x, x ni tak boleh potong. Sebab dalam sem lepas saya jumpa ramai student yang dia potong ni x, so tinggal sin 3 bahagi dengan sin 5, tekan calculator dapat jawapan salah. Okay, yang x ni tak boleh cancel out sebab dia terikat dengan limit ni. Okay, next page. So how do we do for this question? assume that sin 3x and sin 5x is the multiplication of 1. Okay, so kita just darab satu je lah kan, sebab any numbers when it is multiply with 1, okay, dia akan jadi diri dia sendiri. Okay, so kita just multiply with 1, both up and down side ni. So since any fraction with the same numerator and denominator, kalau for example kalau 2x divide by 2x, so kita boleh potong-potong equal to 1. So maksudnya kalau kita letak kat sini x square, letak sini x square pun tak kisah, sebab dia boleh potong-potong equal to 1, and then dia akan jadi original function. Kita letak apa-apalah, kalau 3x dekat sini 3x pun tak ada jadi masalah. Okay, so in this solution we can see that value of 1 ni dia change into 3x divide by 3x. Okay, 1 yang bawah ni 5x divide by 5x. Okay, why is it like that? Because we want to use the squeezing theorem yang limit x tends to 0 for the function of sin x divided by x. Okay, it will become to 1. So we need to form this kind of function. Okay, sin x divide by x. Not only this one, kalau sin 2x mesti divide by 2x. Sin 3x divide by 3x. Sin 5x divide by 5x. Sebab tu kita kena form 3x divide by 3x here. Okay, sebab 3x kalau potong akan jadi 1, which is sama dengan yang ni. 5x pun boleh potong jadi 1. Okay, so kenapa kita letak macam tu? Sebab kita nak dalam in the form of ni lah, macam ni. Macam ni. Okay, so kita akan dapat dekat sini sin 3x divide by 3x, sin 5x divide by 5x. So this term will become 1, and also this term will equal to 1. Okay, so dia jadi macam mana? Kita tengok kat sini. Okay, kita buat modification sikit. Kita alihkan tempat dia. Okay, 3x bring it here, and 5x bring it here. So it will become sin 3x divided by 3x, and 3x kat sini. Yang ni yang asal letak sini. Same with this 5x. Okay, bring it here. So it will become sin 5x divided by 5x. So dekat sini 5x yang ni. Okay, so with using squeezing theorem, okay, this term, okay, this term and this term will become 1 by using squeezing theorem lah. Jadi 1. Okay, and then yang belakang ni, limit x approach 0 for the function of 3x. Okay, dia akan jadi macam ni, dan 5x jadi macam ni lah. Okay, sebab yang ni dah jadi equal to 1. Okay, then okay, yang tadi ni, if we directly substitute the values of x, okay, we will get 3 multiply with 0 divide by 5 multiply with 0, which will resulting in 0 divide by 0. So ini error. Okay, so macam mana nak buat? Kena potong x ni. Okay, so cancel out both x, okay, up and down. Okay, so kita akan dapat limit x approach 0, 3 over 5. So it is equal to 3 over 5. Okay, let's take a look at another example involving limit of trigo function. Okay, this one, question number 14. Okay, tangent 2x divided by sin x. Okay, remember that we have this theorem. Okay, limit x approach 0 for the function of sin x divided by x is equal to 1, and limit x approach 0 for the function of 1 minus cos x divided by x, it will become 0. Okay, so kita ada dua squeezing theorem, and then we want to solve this question. Okay, limit x tends to 0. Okay, tangent to x sin x. So kita split out dia. Akan jadi tangent to x, okay, multiply with 1 over sin x. Kenapa 1 over sin x? Sebab sin x is the denominator. So it must be in the lower fraction, dekat bahagian bawah tu. Mesti 1 over sin x lah. Okay, and then tangent to x, okay, boleh jadi sin to x divided by cos to x. Okay. Okay, in order to use squeezing theorem, we need to find the function in the form like this. Okay, sin x divided by x. So for this question, we have sin 2x. So we need to form sin 2x divided by 2x. Okay, 2x kat bawah, 2x kat bawah. Kat atas dan bawah. So sin 2x kita dah ada. So we need to make sure there is 2x dekat bahagian bawah. Okay, so macam mana nak buat? Okay, kita kena make sure bahagian bawah ada 2x. So kita buatlah bahagian bawah 2x. So atas pun kena letak 2x juga. Okay, kenapa letak atas bawah benda yang sama? Sebab kalau kita cancel out, it will become 1. Okay, akan jadi original equation yang ni lah. Okay, please note that this sin x dengan sin 2x cannot be cancelled out. Okay, so we will use this squeezing theorem for this term, sin 2x divided by 2x. So kita kena buat modification lah. 2x ni bring it dekat bawah sin x. Okay. So this term will become 1 times limit. Okay, the remaining function is 1 divided by sin x. Okay, 2x divided by cos 2x. Okay, and also we can apply squeezing theorem for this term. Okay, kalau awak nampak kat sini, okay, actually this squeezing theorem, the first squeezing theorem, kalau kita buat limit x tends to 0 for x divided by sin x, okay, it also will become 1. Okay, untuk yang ni ada certain buku, kalau awak refer textbook, ada certain buku dia kata kalau yang ni limit x approach to 0, function ni kita terbalikkan x divided by sin x, it also will be equal to 1. Tapi yang ni tak boleh terbalikkan, yang ni saja. So we want to apply this theorem for term yang ni. Atas ada x, bawah ada sin x. So kita nak apply yang ni. So in order to apply this theorem, we need to do some simplification. Okay, ni saya buang dulu. Okay, sebab tak muat. Okay, so we need to arrange x dengan sin x ni satu tempat, sebab we want to use the squeezing theorem tadi. So the remaining term is 2 divided by cos 2x. Okay, so this term will become 1. So 1 times limit x tends to 0. Okay, ni limit yang tinggal, function yang tinggal lah, 2 divided by cos 2x. Okay, so yang ni satu dah tak adalah, dah selesai lah. So from here we can directly substitute the value of x, okay, with 0. So we got 2 divided by cos 2, 0. So it will become 2 divided by cos 0. Okay, cos 0 is equal to 1. Okay, tekan calculator je. Cos 0 is equal to 1. So 2 divided by 1. So the final answer will be 2. Okay, next for question number 15. Okay, limit y tends to 0 sin 2y divided by y square. Okay, so we need to use squeezing theorem, because if we directly substitute the value of y equal to 0, okay, we will get 0 divided by 0, which is error, okay, ataupun undefined. So we need to use squeezing theorem. So squeezing theorem, ingat dia kalau limit tends to 0, sin x divided by x equal to 1. So this time the term yang kita dapat kat sini sin 2y. So we need to make sure we have 2y in the denominator as well. Okay, sebab kita nak guna squeezing theorem kan, yang ni mesti sama dengan ni. So kita dekat ini ada 2y, kat bawah pun mesti ada 2y. Okay, so y ni dah ada, so kita just need to times dengan 2 lah. 2 atas, 2 bawah. Y 0. Okay, then kita rearrange. Okay, sin 2y. Bawah kita nak letak 2y, di mana kita ambil 2 kat sini, y kat sini. So the remaining term is 2 kat atas, and kat bawah ada tinggal lagi 1y. Okay, so this term will become 1, okay, using squeezing theorem. So 1 times limit of the remaining term, which is 2 divided by y. Okay. Okay, so the remaining term is limit y tends to 0, 2 divided by y. So if we directly substitute, and then we need to directly substitute lah the value of y, sebab kita tak boleh nak buat apa-apa lagi kat sini kan. Dah dalam the simplest form lah ni, 2 divided by y. So directly substitute kat sini. Okay, and then 2 divided by 0 is met error lah. Okay, so I think there's be some problem with this question. Soalan limit tak boleh dapat error dalam exam ke dalam assessment nanti. So kita cancel lah soalan nombor 15 ni. Okay, so we proceed with soalan nombor 16 tadi dah buat. Okay, so yang ni salah lah Okay, please proceed by doing the tutorial in your tutorial book. Okay, by doing page 8, okay, homework 8 on page 8, and then proceed with homework 9 on page 9 by doing all the questions about limit at trigo function, limit at trigo function, and then page 10 until page 13. Okay, jawapan dia semua kita akan discuss dekat tutorial class. Okay, so see you next time. Okay, Assalamualaikum warahmatullahi wabarakatuh.